you have to check this, that everyone should be in video mode. I think even though I have told you, your video is on at this stage, but no one is open. So that indicate you must know the protocols that told during the lectures. Second thing, when we have started the lecture from last week, I have focused on your career opportunities and scope of chemistry after graduation, and from which path you have to go. I think within this last week of that is 7 days, you might have think over it, that what will be your target, and how you can achieve, how much time you will take to achieve that target, and for that how you can do the efforts to achieve that target. So what to achieve, when to achieve, and how to achieve, that is a very important part that we have discussed on last lecture. And always my opinion is that everyone should join the higher education, and if those who are not able to join higher education, then immediately you should start your business. As far as the chemistry is concerned, there are a lot of things are there in your surrounding. There is a very wide scope of chemistry to start as a entrepreneur or to start a startup. There are so many facilities are available with the financial conditions, supports by various banking sector as well as government sector. Government schemes are there. So you should initiate if you have any kind of idea which is something out of box regarding the very normal problem surrounding you, and then you can imply that one to initiative. And after this invention, you should definitely go to the startup and entrepreneur. So that is nothing but only higher education is not the way. There are so many ways are there, so we have already discussed. And I think uh, now we can start with our regular syllabus. And within this 7 minutes I have observed there are 117 students are there. So what will happen in this case, till that I am not doing the auto mode regarding the auto admission and auto attendance. Probably after this lecture I will go to OIT department and I will do that. Some required some accessories are required there, or we have to download some important keys for that, and that will go atom. Because what will happen when once you have started the lecture, the students are waiting for join. So if there is possibility that they can join directly without my permission, then it is very easy. Because once we have started the lecture and then students are asking regarding the admit in Zoom, that facility is there. That is when we have started the lecture, on the screen that indication is coming, so we can directly admit that one. But in this case, in this Google Meet, that process is not there, and that's why it having some drawback regarding this. But probably today I will take the solution for this, and so from next lecture, might be there is no need of permission of me, because directly you should be joined. And one from your side, that is who will take responsibility that, to take the screenshot of total attendance of this lecture, and send on our WhatsApp group of TYBSC. So we have to submit that screenshot to the Google form that college as well as the Red Shiksha Samstha has provided to us. After completion of every lecture, we have to give the attendance, how many students are there of total strength, and we have to submit this photo also. So that's why there is need of screenshot. So anyone from your side should take the screenshot. So that is very easy to observe the total number of student participants. I think it is more than sufficient time that no one is trying to I think join now, because 119 is the strength is there, so that enough for us, so we can start with our syllabus. And if you require anything regarding your career, then you can directly contact with me. So that is also very essential after the uh, okay. Can you see the PPT?
Yes, sir.
Okay. So, as on the last lecture, at the very last moment, I have told you that I will teach you the NMR spectroscopy and combined problem. This is the BSc third semester fifth, and paper is BCT 503, paper number 11, that is organic chemistry, and in that unit number 4 is the NMR spectroscopy, and fifth one the combined problem. So I will first start with the NMR spectroscopy. As we know that the paper number 11, which is concerned with organic chemistry, there are 6 units are there. First is introduction to spectroscopy of 3 periods, then UV spectroscopy of 8 periods, IR spectroscopy 9 periods, NMR spectroscopy 10 periods, mass spectroscopy 9 periods, and combined problem based on UV, IR, NMR, and mass is of 6 to 7 lecture. So that is nothing but these are the 2 credit paper with 45 lectures are required. So this is the total units which are included in the organic chemistry, and this is the whole paper which is based on spectroscopy and which is very very essential, not only in industry but also in research as well as higher education. This is the very essential and compulsory part that you should know very well, and that's why. And this paper is similar to the mathematics, so that is nothing but you can get a very good score in this paper. So writing is very less, that is no description part is there. Whatever the part of description is there, it is very less, and you have to imagine that to solve the problems, and always it is very interesting. All topics are there, and this is totally new for chemistry students. And based on this theory, because why I'm again and again tell you that this part at BSc third level you should clear the basic concept of all spectroscopies, because based on this whole mm, career is depend. Those who are interested to join higher education, those who are interested to join PhD and research institute and R&D center, this is required. It is very very compulsory, and that's why you must focus, or you must see in detail in this. No doubt this situation is going on probably next 1.5 month. We are hoping that the situation will try to going to decrease, because we have observed now the graph is going on still increasing, so the curve is not going downward. That is nothing but when we can find out lambda max by using UV, we have observed a shape. So like that curve is not started, we are not at the highest peak, I think. So till we require some more time, that is 1 and 2 months may be required, and that is nothing but this virtual classroom is going on continuously till the normal condition is not there, and that's why you have to take down you have to prepare Google Classroom that I will prepare shortly, and then you should join there. I will send you the Google code, classroom code, so you can join that. So whatever the material as well as assignments, quiz that we will give you, you should be uh, attempt that, and you should download the material which is required for this paper. Okay, so this is the part that probably we can start with uh, very soon, that is the Google Classroom. Now when we can see the NMR spectroscopy that I will take, the contents include introduction, principle, instrumentation, scheme diagram, magnetic non-magnetic nuclei, shielding de-shielding, chemical shift, peak integrations, spin-spin coupling, coupling constant, application and problems. These are actually the different parts of this topic that we will see in detail one by one. Now introduction, that is the spectroscopy. It is the study of interaction of electromagnetic radiation with matter that can be mm, atom, that can be molecule, or that can be ions. So spectroscopy, it is the study of interaction of electromagnetic radiation with matter. So what is matter? Matter is nothing but it may be atom, it may be molecule, or it may be ion. So here when we can focus on spectrometer, spectrometer is something which can measure the presence of particular compound or particular molecule. So it is an instrument which can measure the presence of compound or which compound is there. That confirmation is carried out by using the instrument, that is the spectrometer. And spectrum is nothing but it is a on paper we have observed some peaks. So it is a plot of amount of light absorbed by the sample versus wavelength of light. And here we can observe the uh, spectrum that is on paper, that is on graph paper. We have observed some peaks, the amount of light absorbed, it is called absorbance. So here when we have take the ECG that everyone actually observed how ECG look like. So such kind of signals are obtained uh, from the instrumentation, and on computer we have observed such peaks. And when you can take the print, that paper is nothing but the spectrum. So spectrum is the plot of amount of light absorbed by the sample versus the wavelength of light, and the amount of light absorbed is called as absorbance. So absorbance versus frequency, we have observed the plot the graph, and we have observed the peaks, and that peaks are particular functional group and hydrogen of particular atom. Now what is meant by electromagnetic radiation? So electromagnetic, it is a form of energy that is all around us. It is a form of energy having both electric as well as magnetic characteristics. So here this electric and magnetism were once thought to be as separate forces. So electric field is separate and magnetic field is totally separate. So Maxwell developed this theory of electromagnetism. So he has first combined uh, uh, initially electricity is separate, magnetism is separate, and Maxwell has carried out the theory based on electromagnetism. So study of electromagnetism that deals with how electrically charged particles interact with each other and with magnetic field. So in the presence of magnetic field, how the particles they can electrically charge interact with one another, and that's why it is called as electromagnetic field. So in the presence of electromagnetic field, so that is nothing but there are two kind of energies are there. One is electric energy and the second is magnetic energy. And everyone know that electromagnetic radiations that is nothing but the it is the electromagnetic waves which are synchronized oscillations of both electric as well as magnetic field that propagate the speed of light through a vacuum. And this oscillation of the two fields which are actually perpendicular to one another and perpendicular to the direction of propagation, wave propagation, and that can forming a uh, transverse wave. That is nothing but one is suppose vertical, second is horizontal, right? So did you understand what is the electromagnetic radiation? So electromagnetic radiation consists of electric and magnetic waves which are synchronized and that are perpendicular to one another. So this oscillation of these two fields are perpendicular to each other and the perpendicular to the direction of propagation, that is the wave propagation, and which can form a transverse wave. So that is very important thing. So everyone know that at I think wave equation and wave motion, that part you have learned at 11th and 12th standard, where you have seen this diagram. Anyone can say? कोण सांगू शकेल का? हे इलेक्ट्रोमॅग्नेटिक वेव्स तुम्ही पाहिले का अगोदर? सांगा. वेव मोशन झालाय का? अरे हो का नाही?
अरे हो का नाही?
Yes, sir. Yes, sir.
हा मग बोला बोला ना काहीतरी. Okay, in this case, when we can see this nature of electromagnetic radiation, that exhibit actually dual nature. Okay, that is nothing but it can form a particular as well as waveform. And in the study of the spectroscopy, that emphasize on the waveform of the radiations. So these all radiations when propagate to the in the form of waveform that can produce electric field and magnetic field, and their direction is perpendicular. So if you observe here, this is the electromagnetic, that is nothing but this is magnetic field which is perpendicular vertical direction, and this electric field is horizontal direction. And the distance between what is the wavelength? The distance between two successive, what we can say?
Crust or true.
Yeah,
Or true.
yeah. So that
Yeah.
part you all learn
Yeah.
at
So
the
that part you all learn at the
11th standard. 11th standard. Now, so when we can see the electromagnetic spectrum, short wavelength means the frequency will be higher because one cycle can pass in a shorter amount of time according to the University of Wisconsin. Similarly, a longer wavelength has a lower frequency because each cycle takes longer time to complete. And we know that in this case we have observed that is the wave motion. We have observed these basic terms, that is frequency, wavelength, amplitude, I think wave number, that you already know. So number of waves produced in each second, it is called as frequency. So that is nothing but when oscillation, one oscillation that can be takes place. And wavelength is nothing but the distance between two successive waves, that is crust and trough. And amplitude is nothing but the maximum distance of wave extended beyond its middle position. So it is called it as corresponding amplitude. Similarly, we can also find out on this basis the energy of radiation as well as the wave number also. So this is the trough and this is the highest peak is there. So the wavelength lambda and amplitude, that is the highest. Uh, we can observe the maximum displacement of the wave from the x-axis. So that is the amplitude. So these are the basic terms of wave motion that you have already learned at the 11th-12th standard. On that basis, when we can observe the electromagnetic spectrum having a range very short wavelength, that is gamma rays, to the very long wavelength, that is the radio waves. And here the visible region of the spectrum extend approximately over the wavelength 400 to 700 nanometer. So this is the only region, that is 400 to 800 nanometer, that is visible for our eyes. Then the shorter wavelength being with blue end, while the longer wavelength is of a red color. So that is nothing but in this case the wavelength from shorter to longer, that is nothing but from gamma rays to radio rays, the color has been changed from blue to the red, and only the region that is visible region 400 to 800 nanometer that we have to observe. Then wavelength between 400 to 200 nanometer, it is mostly for near UV rays, that is UV region is there in the spectrum, while the wavelength above 700, that is above 800 nanometer to approximate 2000 nanometer, is for UV. So on that basis, the electromagnetic spectrum, we have observed the 7 different regions are there on the basis of electromagnetic radiation. So depending on the energy, the electromagnetic radiations are classified into the 7 different regions. And here, when we can observe the gamma rays, which having the shorter wavelength, the wavelength goes on increasing from left to right, that is X-ray, ultraviolet, visible, that is 400 to 800 nanometer, that is only we have observed in terms of color, infrared, microwave, and radio waves. So from gamma rays to radio rays, the frequency, that is the wavelength goes on increasing from shorter to longer, and frequency also goes on decreasing, while energy goes on here, in that case, higher to lower. So that is nothing but, in this case, when the shorter wavelength is there, the excitation is that waves we can observe is very very compact. And then as the wavelength goes on increasing, distance goes on increasing. If you observe here, microwave and radio waves. Okay, so wavelength goes on increasing from gamma to radio waves. So when we can see the electromagnetic spectrum, broadly we can observe the wavelengths, frequencies and energies. So if we see this relation, how we can obtain this relation? That is the energy of radiation. What is the energy of radiation? Anyone can say the equation? What is the Planck equation of energy? Anyone can, which is how we can define the relation between energy, wavelength and frequency?
E is equal to HV.
E is equal to h nu, that is the energy of radiation, where h is the Planck's constant and nu is the frequency of radiation. So here c is the velocity of light, and we know that nu is equal to c upon lambda. So the frequency is inversely proportional to wavelength. If you observe here, frequency is inversely proportional to wavelength, so that everyone know that. And when we can feel this value, energy is also inversely proportional to wavelength. And that's why when we can see observed here, that is the wavelength goes on increasing, energy goes on decreasing. So that is nothing but higher energy is required for excitation of these gamma rays as compared to radio waves. Okay, so this is the relation, everyone know that. And we can find out this in terms of angstrom unit, nanometer, as well as micron. So we have given in different units these types of radiation according to their wavelength. So these are the different kind of radiations are there. That is electromagnetic radiations, that is gamma rays, x-rays, uv rays, visible rays, ir, microwave rays and radio waves. So these are the different waves, radiations are there, and that are based upon the wavelength, that is the which are increasing from lower wavelength, that is from gamma, to corresponding radio waves. So this diagram is always asked to draw, and question is always asked on this part, short question. Now when you can see the nature of interaction between electromagnetic radiation and matter, that we have just seen the definition, spectroscopy, that is the interaction of electromagnetic radiation with matter. So matter may be atom, maybe molecule, or maybe ion. So what kind of interaction is mostly takes place? So if you observe here, the interaction of electromagnetic radiation with matter is takes place by absorption or emission or scattering. So electromagnetic radiation may be absorbed by the matter, it may be emitted to the matter, or it is scattered by the matter, and that can give the study of matter with respect to the qualitative as well as quantitative analysis. So on this information, we can easily find out the qualitative analysis as well as quantitative analysis of the atom or molecule or ions. So do you understand how the nature of electromagnetic radiation is takes place with matter? It may absorb by the matter, it may emitted through the matter, and it is scattered. And on that basis, we can study the nature of matter, qualitative as well as quantitative. So here, the effect of electromagnetic radiation on interaction with matter actually depends upon the energy associated with radiation. So that is nothing but this interaction of electromagnetic radiation with matter is depend upon the energy which is associated with all these different kind of radiations, that is 7 different regions we have observed. So very energetic radiation is gamma rays, UV rays, and X-rays that can causes electron to ejected from the molecule. So that is nothing but the electron can be removed from the molecule by using the gamma rays, UV rays, and X-rays. So radiation in this infrared region, that is after from left hand side of the UV. So initially we observe gamma, then X-ray, then UV, then left side of the UV is visible, and then IR. So this IR region of the spectrum having much less energy, very less energy as compared to the UV and X-ray, and that's why they can causes vibration of molecule. Okay, so that is nothing but it is a very important concept regarding this. That is in highly energetic radiation, uh, in the UV and X-ray, or in the UV and visible, as far as the organic chemistry is concerned, there is vibrational rotational of the molecules takes place. While in the radiation in infrared region, as compared to UV, which is from left hand side, so it is much less energetic as compared to UV and visible, and that's why they can causes only vibration in the molecule and not vibration as well as rotation. So combined energetic excitation is not takes place over here. Okay, so that is the difference between UV and IR. Now and we can see the microwave radiation. Now we can move still towards the left hand side, and as we know that from still towards the from left to right region, the energy goes on decreasing. So that is nothing from gamma rays to X-rays to UV to visible and to IR. Energy goes on decreasing, and after IR there is microwave region, and it is still very less energetic than infrared radiation. So it can neither include electronic transition. So from one energy level to other energy level, that is electronic transition, which is takes place in UV, is not observed in microwave, as well as nor can be causes vibration, which is observed in the IR. So there is no electronic transition as well as no vibration. Only rotation is takes place over here. So what is the difference between UV, IR, and microwave? Did you understand? UV मध्ये काय होतं? In UV spectroscopy there is electronic transition, while in IR what will happen? There is vibration of the molecules takes place, and while in microwave what will happen? There is rotation of molecule. Those who have opened their audio, please mute. During lecture, your video is on, but your volume is always mute. Be remember, because such kind of interaction is there along with electromagnetic radiation. So that can cause some other kind of waves, not only electric and magnetic field. Okay, so be remember that when such kind of spectroscopy is going on, some other radiations do not interfere. Okay, so did you understand what is the difference? Yes or no?
Yes, sir.
Okay, so in UV, which is on your left hand side, as far as the electromagnetic spectrum is concerned, that is initially there is gamma rays, then X-rays, then UV. So UV radiation, what will happen? There is electronic transition is takes place. While in after UV visible, there is IR region, and in IR region we have observed vibration of the molecule. So within the molecule there is vibration, and then after IR there is microwave. So it can get the rotation of the that is rotational excitation is takes place, and that's why they can use the microwave radiation. And from the UV the energy goes on decreasing, and towards the right hand side of the electromagnetic spectrum, that is from your right hand side, there is a wave, radio wave radiation. this radio wave radiation is extremely low energetic as compared to microwave, as compared to IR, as compared to UV, that can react with the nuclei of certain atoms only. We remember radio radiation is interact with only nuclei of certain atoms which exposed to certain kind of magnetic field. So on the basis of this magnetic field, radio waves which are very low energetic, they interact because they are very less energy. And if you, we know that if you have very energy, then you can jump from 5 feet, 10 feet, 7 feet. But if you have no energy, energy goes on decreasing, then it is very difficult to do such kind of thing. So here also same kind of observation is there. So from radio waves, which is extremely low energetic, radiations are there, and which react with only nuclei of certain atoms, only nuclei of atom. And that is because of when we can expose that atom or molecule in the magnetic field, and that should be a strong magnetic field. Now on the basis of this UV visible, that is electrospectrum, UV, that is ultraviolet and visible radiations or region, is based upon electron transition, and that is called UV spectroscopy. So in the UV spectroscopy you will observe electronic transition, while in IR spectroscopy there is a infrared radiations are there. So generally infrared radiations are used, and in that case which kind of excitation is takes place? There is a molecular vibration excitation is takes place. In microwave spectroscopy, you will observe the microwave radiations can be used, and that can give the rotational excitation of the molecule. Similarly, in NMR spectroscopy, we used radio waves, and there is excitation of nuclear energy level because there is interaction with nuclei of certain atoms in presence of strong magnetic field, and that's why the excitation of the nuclear of the nuclear energy level is takes place. So did you understand? On the basis of radiations are used, spectroscopy is broadly classified into ultraviolet region, infrared region, microwave region, NMR, that is radio wave region. आणि म्हणून ह्या पूर्ण सिलेबस मध्ये तुमच्या लक्षात येईल, पहिल्यांदा इंट्रोडक्टरी पार्ट आहे, त्यानंतर युव्ही स्पेक्ट्रोस्कोपी आहे, त्याच्यानंतर IR स्पेक्ट्रोस्कोपी आहे, त्याच्यानंतर NMR स्पेक्ट्रोस्कोपी आहे, आणि त्यानंतर मास ही ह्याच्यापेक्षा वेगळं येतं थोडस, आणि त्यानंतर कंबाईन प्रॉब्लेम. तर तुम्हाला मला वाटतं आता बेसिक पार्ट इलेक्ट्रोमॅग्नेटिक रेडिएशनचा समजला असावा. समजतंय का? बोला.
Yes, sir.
Okay, so we will move further. Okay, so we have already seen the energy of radiation, that is E is equal to h nu. H is the Planck's constant, and how that can be a relation that we have already discussed, so there is no need to give. So actually in this whole scenario, what will happen? The excitation is takes place, and that having different nature, that is electronic excitation, transition state is there, vibrational is there, rotational is there, and there is a only excitation of nuclear energy level is there. So the sample at equilibrium position absorb the radiations, so these different radiations are there. Then what will happen? It undergo excitation, so it get excited, so excited state is there, and after that excitation it come to the ground state, so that is a relaxation. And during this relaxation we have observed the spectrum, so it can emit certain kind of radiations energy, and that energy is converted to the instrumentation part, and that gives a spectrum. So that is nothing but this is the basic path of any kind of spectroscopy. The same thing is happen, so only principle is different, only the kind of absorption of radiation is different, and after excitation the relaxation process is little bit changed, but whatever the steps are there, these are the common steps which are observed in UV, IR, NMR. Okay, now we'll go further. Introduction to NMR spectroscopy. So NMR spectroscopy is nothing but nuclear magnetic resonance spectroscopy. So commonly it is called as abbreviation is NMR. So it is generally called NMR. So no one can say that it is nuclear magnetic resonance spectroscopy. But this long form of this NMR indicate a very clear indication regarding what is the N. N is nothing but nuclear, because it is related to the nucleus of the atom. Magnetic field is there, right? Because there is electromagnetic field we have to supply. Then it undergo, what is this? Resonance. So when it undergo excitation and come back, the resonances occur, and this resonance is converted to the spectrum, that is called spectroscopy. So it is a very powerful non-destructive analytical technique which is used to characterize the organic molecule by identifying carbon hydrogen framework within a molecule, and it's used related to the MRI in medicine. So NMR spectroscopy is nothing but it is a nuclear magnetic resonance spectroscopy, which is a powerful non-destructive analytical technique. It is used to calculate or characterize the organic molecule. We have to find out the structure of the unknown compounds, and during this process we can find out the carbon hydrogen framework within a molecule. And similar to such kind of function in medicinal field, for scanning, this technique is used, that is NMR, and it is called MRI scan, right? So magnetic resonance imaging, which is used in, where this is used, कुठे वापरतात हे MRI? कुठल्या स्कॅनिंग साठी वापरतात?
ब्रेन स्कॅन.
Brain scan.
हा, म्हणजे आपल्याला हे माहिती पाहिजे की स्पेक्ट्रोस्कोपी जरी आपण इथं शिकत असलो तर त्याचा वापर हा फक्त रिसर्च साठी नाही, इंडस्ट्रीसाठी नाही, हायर एज्युकेशन मध्ये नाही, तर आपण आता आपल्या मेडिसिनल फील्ड मध्ये सुद्धा ह्याचा वापर आपण करतो, डेली ह्याच्यामध्ये त्याचा वापर होतो. अँड दॅट्स वाय दिस इज व्हेरी व्हेरी इम्पॉर्टंट पार्ट. So in this case, generally, what is the source of energy here? We can use radio waves. Means UV, we can use UV rays, IR, infrared, microwave, spectroscopy la microwave, and in NMR spectroscopy we use radio waves, which having a very long wavelength and very low energy and frequency that we have observed from the electromagnetic radiation spectrum, right? So this is a very important statement. So when energy is low, radio waves interact with molecule because it is very less energy is there, and they can change the nuclear spin because it interact with nuclei of the atom or nuclei of the molecule. So it can change the nuclear spin of some elements of that molecule. And which are that one? Generally hydrogen and carbon. And that's why we have written over here that it can be used to characterize the organic molecule by identifying carbon hydrogen framework. So here this NMR spectroscopy that include H1 and C13 when exposed to strong magnetic field. So when we can supply a strong magnetic field, there is absorption of radio waves frequency by the nuclei, and that can give a change in nuclear spin, excitation takes place, and that can create a resonance. That resonance is absorbed by the instrument, and that can give the spectrum. So it is called as nuclear magnetic resonance spectrum. So did you understand why it is called as nuclear magnetic resonance spectroscopy? Because it is very low energetic and it is interact with the nuclei of the molecule, and that are include only H1 and C13 because it is very less energetic, and from that we can easily find out the exact position of carbon and hydrogen in a molecule. And once we can find out, so we can predict. So if you synthesize any compound which is unknown, we can extract any molecule from the environment, from nature, and then you have to identify the exact molecule. We require NMR spectroscopy. So this is the most powerful analytical technique in research. It is always used. Without NMR we cannot do anything, and that's why this is a very very important part of the your syllabus. So did you understand what is meant by nuclear magnetic resonance? Definition is always asked because in this COVID-19 pandemic, in virtual class, there is possibility that the exam will be taken online. That is nothing but in terms of quiz, in terms of 1 to 2 line short question or one para short question you have to write on your mobile or laptop. So when the exam will be there, so that's why you must know how to write down in your mobile, how you can write down on by using, if you are using laptop. So such kind of situation is required in next month, because definitely there will be a quiz, definitely there will be a internal that ISC, such kind of things will be going on. So you must focus that which part is very important, what is the definition, which is because when we can carry out online test, now there is no need to write down in detail, but you have to write down the specific words that are very meaningful. So you have to summarize the things in 1 or 2 lines. So that is a very important thing that this COVID-19 teaches. Okay. So did you understand the introductory part of NMR spectroscopy? Yes or no?
Yes, sir.
Any doubt is there?
Yes,
Please
sir.
ask, because this is the drawback of online teaching. Really, I appreciate this, because in regular class, definitely there is interaction between student and teacher is takes place. We have observed how many students understand the part, and we can repeat it or we can ask the other student. And here is no such kind of interaction. Second thing, in Zoom and Google, when we can compare, in Zoom we have observed sideline, in which we have observed the each and every person, what he or she is doing, whether it's his video or her video is on or not. So such thing is not observed in Google Classroom. That was the drawback, and that is very difficult to judge whether the real students are there, or after starting the lecture whether they are just on and going something and doing eating, and that other things are also going on simultaneously. So such kind of scenario that we have to observe, and that's why in Zoom every student should open their video, and that we have directly observed from both the side in real shape. We have observed number of students, what their activities are going on simultaneously. So such kind of check is not there in Google Classroom, but we have used this one because it is free and a little bit safer as compared to the Zoom. Okay, so basic thing, now we can move further for the development. So whatever the NMR is in the form of MRI today, in the form of a very sophisticated part of NMR is today, but it actually start in 1924. So this Paul has suggested certain atomic nuclei that should have properties of spin and magnetic moment, and as consequence of explode to the magnetic field, that gives the splitting of their energy levels, that is spin and magnetic moment of the properties of nuclei, so atomic nuclei. So he has observed such kind of observation, and on that basis the NMR is started in 1924. Then scientist Rabies et al has predicted and observed the nuclear magnetic resonance. So the first NMR was taken by Bloch and Pursley in 1945 separately for water molecule and paraffin by the Pursley, and they have actually started the NMR spectroscopy. Then Ohrhauser effect, that is nuclear Ohrhauser effect, has been developed in 1953, and the most important part in the history of NMR, that is the development is made by Ernst and Anderson in 1966, that is the Fourier transfer of NMR. And this is a very important part, because whatever the drawback are there before Fourier transfer, that has been overcome in this case, and once you use this technique, then it is very easy to analyze the molecule which are unidentified. Then the 2D NMR technique is developed in 1975 by Ernst and Giner. Then NMR is useful for the determination of protein structure by Wurthrich. And in this continuous growth of NMR in 1990 region, that gives a 3D NMR printing, and along with that they use H1, C13 and N15, such kind of triple resonance is carried out simultaneously. So such kind of information along with uh, using hydrogen, carbon and nitrogen determination by using the triple resonance. So that technique is used in the 3D. And then ultra high field is there. That is nothing but in 1997. Before that, we having the frequency of the NMR instrument is 60 megahertz, 120 megahertz. Nowadays, in Shivaji University Chemistry Department, there is a NMR of 300 megahertz, while in Solapur University, there is a NMR of 500 megahertz. While when we can go to the Pune University, they having one 500 and one 800 megahertz instrument. And when we can move to the NCL, like such kind of research institute, they having very high megahertz, that is nothing but 1000 megahertz instrument is there. So such kind of development is going on in the NMR, which is started by Paul, and the first NMR is taken by Blausch and Purcell. So such kind of question based on these name of scientists are generally asked in the MCQ. Now, when you can see the history of NMR spectroscopy, in 1945, Pursley and his team at Harvard University, while Bloch and his team in Stanford University, they are working simultaneously for the discovery of the NMR spectroscopy. And the first NMR spectra or spectrum of ethyl alcohol was recorded by Arnold Dharmanti and Packard. While when as far as the Nobel Prize is concerned, NMR spectroscopy, it is very important, because if you observe from 1952 to 2003, there are 4 Nobel Prizes for NMR. So first Nobel Prize was given to the Bloch and Pursley for the discovery of NMR. While in 1991, the second Nobel Prize in chemistry was awarded to Richard Ernest for the discoveries of advanced methodologies, and that can be determined by using NMR. Third Nobel Prize was awarded to the Wurtzich for determination of structure of biomolecules in the solution by using NMR spectroscopy. So that was the third Nobel Prize in NMR. While the fourth Nobel Prize in medicine was awarded to the Paul Lauterbach and Sir Peter for magnetic resonance imaging, that is MRI. So since 2003, we have used MRI scanning, and that is the revolution in the medicine. Otherwise, it is very difficult to know what is how the actually the brain tumor they can be observed by using MRI scanning. So that is a very important discovery, and that's why the Nobel Prize is given to the Paul Ludberg and Sir Peter in 2003. So this is the history of NMR spectroscopy. So did you understand how the important of the NMR spectroscopy is there? Because this spectroscopy having a credit of 4 Nobel Prize. So these are the photos of scientists who has received the Nobel Prize in 1944, 1952 for the development of new method of nuclear magnetic measurement and discoveries in connection there. 1991, Ernest, he has contributed to development of the methodology of high resolution of NMR. That is very important part. And then 2002, Wurtzich for the development of nuclear magnetic resonance spectroscopy that can give 3-dimensional structure of the biological macromolecules, and it is very difficult otherwise to identify, and that's why he has got the NMR get the Nobel Prize. And 2003, that is Lauterbach and Mansfield for the discovery of MRI, that is magnetic resonance imagining. So in this way, the contribution of NMR spectroscopy, as well as its introductory part that we have covered, I think just 3 to 4 minutes are there. So 5 minutes are there. So when we have observed, then in that case, again the student, once they have joined, why the strength is going on decreasing, I didn't know. But whatever I have taken in this lecture, whether there is any kind of difficulties, please open your uh, vi- video. So we have to interact, whether you have any kind of difficulties. यामध्ये कोणाला काही शंका आहे का?
फेसबुकला ऍड असतात.
नो सर.
ओके. शक्यतो लेक्चरला थोडस वेळेवर तुम्ही जॉईन होत जावा. मला वाटतंय संख्या जी आहे ही मगाच्या पेक्षा कमी झालेली आहे. सुरुवातीला संख्या जास्त होती आणि मी मगाशी म्हटल्याप्रमाणे की नंतरच्या ह्याच्यामध्ये संख्या जी आहे ती कमी कमी होत जाते. आता 112 संख्या आहे आणि सुरुवातीला आपण पाहिली की 122च्या आसपास संख्या होती. परंतु ऍडमिशन आपले जास्त झालेत आणि त्या मानाने संख्या जी आहे ही थोडीशी कमी आहे आणि ग्रुपवर तर 170 180 संख्या दिसते. मग त्या ग्रुपवर जे मुलं आहेत ज्यांनी तो ग्रुप क्रिएट केलेला आहे त्यांनी जरा बघा की ती मुलं आपल्याच ह्याच्यातली आहेत का. जर असतील तर ते मग इथं लेक्चरला काय येत नाही ते पण पाहावं लागेल. कारण प्रत्येक आठवड्याचा जो काही तुमचा अटेंडन्स रेकॉर्ड आहे ते कॉलेज थ्रू संस्थेला जातं आणि मग त्या ठिकाणी जर हे सिनारिओ असाच कंटिन्यू राहिला तर तुमची अटेंडन्स ही ऑटोमॅटिकली जनरेट होणार आहे आणि मग त्या ठिकाणी जर अटेंडन्स कमी भरली तर मात्र मग आम्ही काही करू शकणार नाहीये. त्यामुळे जे काही मुलांनी ऍडमिशन घेतलेलं आहे त्यांना तुम्ही तुमच्या माध्यमातून सांगा की बाबा लेक्चर्स आता सुरू झालेले आहेत. पूर्वीसारखं वर्गात आपण अटेंडन्स घेत नाही. इथं जी मुलं प्रेझेंट आहे हे सगळी नावं, कोण किती वाजता जॉईन झाला, कोण किती वाजता त्यातनं बाहेर पडला, परत किती वाजता जॉईन झाला, हे सर्व गोष्टी ही ह्या ठिकाणी समजतात. डायरेक्ट रेकॉर्डिंग होतं ते. आणि त्यामुळं प्रत्येक मुलगा 1 तास बसला का, 2 लेक्चर होते तर 2 तास तो कंटिन्यू होता का मध्येच कुठं तो बाहेर गेलाय परत आलाय, हे जे काही इंटरॅक्शन आहे हे सर्व ह्या ठिकाणी रेकॉर्ड होतं. आणि त्यामुळे ह्या रेकॉर्डिंग मध्ये तुम्ही थोडीशी काळजी घेणं गरजेचं आहे की बाबा लेक्चर आपलं जर 11:30ला असेल तर त्याच्या आधी आपलं सर्व आवरून आपण त्या ठिकाणी बसणं गरजेचं आहे. आणि सलग 2 लेक्चर, तुमचं एखादं सीओसीचं असेल तर ते असे 3 लेक्चर्स तुम्हाला बसायचे दिवसभरामध्ये. तर त्याच्या अगोदर आपलं रेग्युलर जसं कॉलेजच्या अगोदर तुम्ही आवरून बसायचा तसं घरामध्ये ज्या ठिकाणी रेंज आहे अशा ठिकाणी तुम्ही बसणं गरजेचं आहे. आणि शक्यतो तुम्हाला आता ह्या कोविड-19 पेंडेमिकच्या मागच्या 4-5 महिन्यामध्ये थोडीशी सवय लागली असेल तर जवळ एखादी पाण्याची बॉटल वगैरे ठेवा. पण लेक्चर मधनं मध्येच उठून जाणे ते हे करणं तर असं प्रकार नसावा. आणि शक्यतो आता आपण मगाशी पाहिलं लेक्चर चालू असताना इलेक्ट्रोमॅग्नेटिक रेडिएशन मध्ये काही इंटरॅक्शन्स दुसऱ्या रेडिएशनच्या झाल्या मध्ये, त्यामुळं थोडस त्या वेव्ज डिस्टर्ब झाल्या लेक्चर चालू असताना. हा, तर तो प्रकार परत होऊ नये की आपला जो काही हे आहे साऊंड आहे तो म्यूट असला पाहिजे. जेव्हा आम्हाला गरज आहे तेव्हा आम्ही तुम्हाला सांगतो की तुम्ही अनम्यूट करा आणि बोला. जेव्हा इंटरॅक्शन असेल, तुम्हाला एखादा पाठ समजला नसेल तर तेव्हा तुम्ही अनम्यूट करायचं आणि बोलायचं. शक्यतो तो तुमच्याकडनं चालू राहू नये. जेव्हा तुम्ही मोबाईल किंवा लॅपटॉप किंवा कॉम्प्युटर चालू करता तेव्हा त्या ठिकाणी तो जो आवाज आहे तो आवाज तुम्ही तुमच्याकडनं बंद ठेवायचा. जेव्हा तुम्हाला त्या ठिकाणी गरज वाटेल की बाबा हा पाठ मला समजत नाहीये तेव्हा तो ऑन करून तुम्ही विचारू शकता. म्हणजे आपल्याला तो पाठ परत घेता येतो किंवा परत सांगता येतो. तर ह्यासाठीच तो वापरायचा आहे. नाहीतर तुम्ही चालू ठेवलाय, घरामधलं बाकीचं इंटरॅक्शन इकडे समजतंय तर असला पाठ होऊ नये इथून पुढे. आणि मला वाटतंय ह्याच्यानंतर जे काय पुढचं लेक्चर आहे टाइम टेबल नुसार ते त्या ठिकाणी होईल. आणि शक्यतो इथून पुढे असे डिस्टर्बन्स येऊ नयेत याची आपण सर्वांनीच काळजी घेऊयात. आणि जर तुम्हाला काही शंका असतील, काही अडचणी असतील तर तुम्ही त्या ठिकाणी नक्कीच विचारायला हरकत नाही की बाबा सर असं डिस्टर्ब होतोय किंवा काही समजत नाहीये. कारण हे आम्हाला कळणार नाही जोपर्यंत तुमचं इंटरॅक्शन होणार नाही. कॉलेजमध्ये आपण फिजिकली असताना आपण काय करायचो, आपण इंटरॅक्ट करायचो, बरोबर आहे. वर्गात आपल्याला समजायचं की बाबा हे पाठ समजतोय, हा समजत नाही. तर आता तसं व्हायला नकोय. तर थोडीशी काळजी घ्या आणि इथून पुढे म्हणजे ते अनावधानाने होतं असं काही मुद्दामन केलेलं नसतं, कारण आपण आत्ताच या सिस्टीम मध्ये आलेलो आहोत. सुरुवातीलाच आता लेक्चर सुरू झालेले आहेत. बरेच वेळा मोबाईल ऍक्च्युली ऑन करता, जेव्हा तुम्ही त्याला जॉईन होता तेव्हा तुमचा व्हिडिओ आणि ऑडिओ दोन्ही ऑन असतात. तर त्यामधला ऑडिओ बंद करून ठेवायचा, व्हिडिओ ऑन ठेवा आणि मग तुम्हाला ते त्या ठिकाणी बघता येते आणि व्यवस्थित तुमचं सर्व लेक्चर झाल्यानंतर किंवा तुम्हाला मध्ये जर काही शंका असतील तुम्ही त्या ठिकाणी विचारायला हरकत नाही. मला वाटतं मॅडम आता या ठिकाणी येतील लेक्चर त्यांचा असेल हे घेण्यासाठी आणि मग ते त्या ठिकाणी कंटिन्यू करतील. तोपर्यंत
आहे सर, लगेच कंटिन्यू करणार आहे मी.
ओके, आलेला. ओके, मॅडम ऑलरेडी
तमाम
आलेल्या.
सर.
हा मॅडम आलेल्याच आहेत, त्यामुळे काही अडचण नाही. तर मी आता इकडनं लिव्ह करतो आणि मॅडम त्या ठिकाणी काय करतील, त्यांचं लेक्चर हे स्टार्ट करतील. ओके मॅडम,
कंटिन्यू करते मी.
हा.
ओके, थँक्यू सर. प्रेझेंट नाव कोकट सर, एंटायर स्क्रीन म्हणायचं ना, एंटायर ना. आता 2 मिनिट शेअर करू, शेअर म्हणून ना. इथं का हे. Am I audible?
Yes, ma'am.
आवाज येतोय का सर्वांना?
Yes, ma'am. Oh. Yes, ma'am. Yes, ma'am.
आवाज येतोय? हा, आणि स्क्रीन दिसतोय का?
हो. हो.
स्क्रीन सर्वांना दिसतोय ना?
दिसते.
हा, गुड आफ्टरनून टू एव्हरीबडी.
Good afternoon, ma'am.
लेट अस स्टार्ट. गुड आफ्टरनून. काय डिफिकल्टी असेल तर सांगा मध्ये, आणि प्रेझेंटीसाठी एक स्क्रीनशॉट काढून ठेवा आणि नंतर मला पाठवा ग्रुपवरती. ओके.
Okay.
Let us consider about our topic, that is the surface chemistry. We have seen about the surface chemistry, that is the surface is the outermost boundary of the substance, and at the surface its valency is unsatisfied. We call that these forces are the residual forces at the surface, and therefore to satisfy these residual forces, when another substance comes in contact with the surface of that substance, it attracts the other substance, and that other substance gets adhered on the surface of substance, and it is called the adsorption. We have seen in the last lecture, that is the collection or accumulation of the other substance on the surface of substance is known as the adsorption. Also, we have seen the difference between adsorption and absorption. That is, adsorption is a surface phenomena, but absorption is a bulk phenomena. Means in case of the adsorption, adsorbed substance accumulate only at the surface of the substance. It does not penetrate within the body of the substance. But in case of the absorption, the substance penetrates in the body of other substance and gets uniformly distributed. We have seen about this. Also, we have seen about the adsorbate and adsorbent. That is what is mean by adsorbate and adsorbent. या प्रोसेस मध्ये 2 सबस्टन्स आहेत. जो सबस्टन्स सरफेस वरती ऍडसॉर्ब झालेला आहे, दॅट इज द ऍडसॉर्बेट, आणि ज्याच्या सरफेस वरती ऍडसॉर्ब झालेला आहे, दॅट इज ऍडसॉर्बंट. Means in the adsorption of acetic acid on charcoal, acetic acid is adsorbate and charcoal is the adsorbent. We have seen about this in the last lecture. Also, we have seen the characteristics features of the adsorption. That is, adsorption depends upon the surface area of the adsorbent. That is, more the surface area, more will be the adsorption. Therefore, we have seen that the finely divided nickel, platinum, these metals are used as catalysts, then which increases the surface area of the adsorbent. Also, we have seen that is the nature of the adsorbate. That is, if gas is the adsorbate, then if that gas is more easily liquefiable, then it will adsorb on the surface in greater proportion. But the gases which are difficult to liquefy, these are adsorbed in smaller quantity. Then what is the effect of temperature? That is, adsorption is the exothermic process, and generally adsorption takes place at low temperature. When we rise the temperature, then what happens? The adsorbed molecule on the surface gets detached from that surface, and we call that is the desorption. Means adsorption is the reversible process. आणि मी तुम्हाला सांगितलं होतं एक होमवर्क की तुम्ही why the adsorption is the exothermic process, that is heat is evolved in the adsorption. Why it is exothermic? काय पाहिलं का तुम्ही? Why adsorption is exothermic process? आवाज येतोय का नाही?
हा येतोय मॅडम. हा येतोय
येतोय ना, मग बोला की. येतोय ना, मग बोला की. बघा, ड्युरिंग adsorption there is always a decrease in residual forces of the surface. That is, there is decrease in surface energy which appears as a heat. Adsorption therefore is an exothermic process. In other words, the enthalpy of adsorption delta H is always negative. इथे जाऊ का मी? इथे बरीच गर्दी आता. बोललं म्हणजे मुलांना. Adsorption, enthalpy of adsorption, that is delta H is negative. It is exothermic process. The next characteristic feature of adsorption is the reversible character. That is, it is a reversible process. Means, in case of the adsorption, we have seen that there is the accumulation of the substance on the surface of other substance. What happens if that substance remains permanently on the surface of that substance? It does not remain permanently on the surface of that substance, but after some time, it gets detached from the surface of the adsorbent, and that process is known as the desorption. A reversible process is the desorption. That is, the adsorbed molecular species can be removed from the surface of the adsorbent, and this process of removing an adsorbed substance from the surface on which it is adsorbed is called as desorption, or it is also called as negative adsorption or deadsorption. That is, the substance gets detached from the surface. Adsorbate can be removed by increasing the temperature or decreasing pressure. This figure indicates this another substance gets attached or adhered on the substance of the surface of the adsorbent, and it is known as the adsorption. And in this process, it gets detached from the surface. It is known as the desorption, or also it is known as the negative adsorption. Thus, the forward step forward adsorption, and backward, that is the desorption. Thus, adsorption is the reversible process. And next characteristic feature of the adsorption is it is a selective or preferential process. That is, if we take the mixture of ethylene and coal gas, and if we add the charcoal, then charcoal adsorbs ethylene preferentially. That is, it is the selectively charcoal adsorbs ethylene from the mixture of ethylene and coal gas. Thus, it is the selective or real process. Depending upon, we have seen that the adsorbate gets attached on the surface of the adsorbent. That is, depending upon the types of forces between adsorbate and adsorbent, there are mainly two types of adsorption. If accumulation of gas on the surface of solid occurs by the weak van der Waals forces, adsorption is termed as physical adsorption or physisorption. That is, the adsorbate molecules are held on the surface of adsorbent by weak van der Waals forces of attraction, that is physical forces of attraction. There is no formation of bond. That is, this adsorption is termed as the physical adsorption, or it is also known as the physisorption. When these adsorbate molecules or atoms are held to the solid surface by chemical bonds, the adsorption is known as chemical adsorption or chemisorption. तुमचा ऍडसॉर्बंट आहे आणि ऍडसॉर्बंट सरफेस वरती ऍडसॉर्ब झालेला आहे, अक्युमुलेट झालेला आहे, आणि या दोन्हीमध्ये जर केमिकल बॉन्ड तयार झालेला असेल, दॅट ऍडसॉर्प्शन इज नोन ॲज द केमिकल ऍडसॉर्प्शन or it is also known as the chemisorption. The chemical bonds which is formed between adsorbate and adsorbent may be covalent in nature or it may be the ionic in nature. Chemisorption involves the high energy of activation and is therefore referred as activated. That is, the high amount of energy is required. Sometimes these two processes occur simultaneously and it is not easy to ascertain the type of adsorption. That is the physical adsorption. It passes into the chemisorption as temperature is increased. For example, if we consider dihydrogen means H2. It is first adsorbed on the nickel surface by van der Waals forces of attraction, and therefore it is the physical adsorption. Means hydrogen gas H2 is adsorbed on the finely divided nickel by the weak van der Waals forces. This adsorption is known as the physical adsorption. While if the molecule of hydrogen dissociate to form hydrogen atoms, then these hydrogen atoms are held on the surface of the nickel by the formation of chemical bond, and it is the chemisorption. These are the two types of the adsorption. समजला, फिजिकल adsorption and chemical adsorption. आवाज येतोय का नाही?
हा येतोय मॅडम, समजलं.
काय फिजिकल ऍडसॉर्प्शन म्हणजे ऍडसॉर्बेट आणि ऍडसॉर्बंट मध्ये कुठल्या टाईपचे फोर्सेस असतात? ऍडसॉर्बेट आणि ऍडसॉर्बंट फिजिकल फोर्सेस असतात, वीक व्हांडरवाल फोर्सेस. आणि केमिकल ऍडसॉर्प्शन मध्ये
केमिकल बॉन्ड तयार होतात.
बॉन्ड तयार होतो. दॅट इज द केमिकल adsorption, or it is also known as the chemisorption. Then consider about the characteristics features of the physical adsorption. We have seen that is what is meant by the physical adsorption. That is the adsorbate molecules are held on the surface of adsorbent by weak van der Waals forces. Consider some characteristic features of the physical adsorption. That is the first, lack of specificity. A given surface of an adsorbent does not show any preference for a particular gas as the van der Waals forces are universal. We have seen that in the adsorption is the selective or preferential process, and also we have seen one of the example that is from the mixture of gases, that is the ethylene and coal gas. The charcoal adsorbed ethylene preferentially. But in case of the physical adsorption, as these physical forces, van der Waals forces are universal, adsorbent does not show any preference for a particular gas. That is, which gas from the mixture of gases is adsorbed preferentially on the surface of the adsorbent. It does not show any preference. And thus we can say that physical adsorption, that is, this is one of the feature, that is lack of specificity in case of the physical adsorption. Then second, that is the nature of adsorbate. The amount of gas adsorbed by a solid adsorbent depends upon the nature of gas. We have seen that is क्वांटिटी त्या गॅसची सॉलिड सरफेस वरती किती ऍडसॉर्ब झालेला आहे तो गॅस, इट डिपेंड्स अपॉन द नेचर ऑफ द गॅस. हियर गॅस इज द adsorbate and solid surface, that is the adsorbent. In general, easily liquefiable gases are readily adsorbed as van der Waals forces are stronger near the critical temperatures. The gases which are easily liquefiable are more adsorbed because the van der Waals forces are stronger. And thus, if we see the example, that is our adsorbent is 1 gram activated charcoal, and this 1 gram activated charcoal adsorbed sulfur dioxide. More amount of sulfur dioxide is adsorbed than methane, and also the amount of methane adsorbed is more than dihydrogen, that is H2. Means sulfur dioxide is easily liquefiable gas, and therefore it is adsorbed in greater quantity, that is there is the more adsorption of sulfur dioxide gas on the surface of the activated charcoal than methane and then hydrogen, because the critical temperature of this sulfur dioxide is 630 Kelvin. During last lecture, we have seen about the critical temperature, that is, it is the temperature above which gas cannot be liquefied by applying any high pressure. The critical temperature of methane is 190 Kelvin. That is, it is less than the sulfur dioxide, and therefore the amount of methane which is adsorbed on the surface of 1 gram activated charcoal is less than the amount of sulfur dioxide which is adsorbed on the same amount of adsorbent. Also, if we consider the example of hydrogen gas, critical temperature of hydrogen gas is very low, that is 33 Kelvin. Hydrogen gas critical temperature at this kame 33 Kelvin, and therefore the amount of hydrogen adsorbed on the same amount of the adsorbent. Adsorbent कोणता आहे आपला याच्यामध्ये? हे एक्झाम्पल आपण कन्सिडर केलेलं आहे. याच्यामध्ये ऍडसॉर्बंट कोणता आहे? बोला, आवाज येतोय ना? काही सांगत नाहीत मला. आवाज येतोय का?
सल्फर डायऑक्साइड.
ऍडसॉर्बंट कोणता आहे?
ऍक्टिव्हेटेड चारकोल.
ऍक्टिव्हेटेड चारकोल. ज्या सबस्टन्सच्या सरफेस वरती ऍडसॉर्प्शन होतंय तो ऍडसॉर्बंट आहे. मग कुठला आहे आपला सरफेस? हा ऍक्टिव्हेटेड चारकोल आहे. म्हणजे ऍडसॉर्बंट कोणता आहे? ऍक्टिव्हेटेड चारकोल. आणि इथं जे गॅस कन्सिडर आपण केलेले आहेत, कोणते 3 गॅस कन्सिडर केलेले आहेत? सल्फर डायऑक्साइड, मिथेन आणि हायड्रोजन गॅस. हे काय आहेत? ऍडसॉर्बेट. आणि इट डिपेंड्स अपॉन द नेचर ऑफ ऍडसॉर्बेट. ऍडसॉर्प्शन डिपेंड्स अपॉन द नेचर ऑफ ऍडसॉर्बेट. आणि इथे काय आपण पाहिलं? मोर इझिली लिक्विफिएबल गॅसेस आर ऍडसॉर्ड easily because their van der Waals forces are stronger near the critical temperature. आणि मग याच्यामध्ये आपण 3 गॅसेस सल्फर डायऑक्साइड, मिथेन आणि हायड्रोजन, या 3 गॅस पैकी अमाउंट ऑफ सल्फर डायऑक्साइड which is adsorbed on the same amount of the adsorbent is higher. More amount of sulfur dioxide is adsorbed because it is easily liquefiable. Then methane is adsorbed less than sulfur dioxide but greater than hydrogen, and hydrogen is adsorbed in small amount, that is its critical temperature is lower and it is only 33 Kelvin. समजलंय? काहीही रिप्लाय नाही.
समजलं मॅडम.
का नाही समजत?
समजतंय.
शिकवायचं का नाही? थांबायचं इथंच?
नाही समजतंय.
समजतंय ना? मग बोलत नाही तुम्ही काहीच.
नाही समजतं ना.
Then consider the next feature of the physical adsorption, that is the reversible nature. Generally आपण जनरल कॅरेक्टरिस्टिक्स पाहिलेल्या आहेत ऍडसॉर्प्शनच्या. दॅट इज त्याच्यामध्ये पण आपण पाहिलेलं आहे की ऍडसॉर्प्शन इज a reversible process, that is the adsorbed substance does not remains permanently there, but after some time when it acquires sufficient energy, it gets detached from the surface of the adsorbent, and that is known as the desorption. That is the reversible nature. Physical adsorption of gas by a solid is reversible. Thus, we can write this adsorption, that is the solid plus gas forward, that is gas is adsorbed on the surface of solid plus heat. Heat is evolved during the process of the adsorption, that is adsorption is exothermic process. Delta H is negative. If we consider this backward process, that is backward process मध्ये काय आहे? तर gas molecules are held on the surface of solid. And in backward process, these two become separate, that is solid plus gas. These gas molecules are detached from the surface. This backward process is desorption or deadsorption or negative adsorption, and forward process is adsorption. That is, it is the reversible in nature. more amount of gas is adsorbed when pressure is increased as the volume of the gas decreases, and the gas can be removed by decreasing the pressure. That is, if we increase the pressure on the gas, what happens? What is the relation between pressure and volume of the gas? काय relation pressure आणि volume मध्ये? They are directly proportional or inversely?
Inversely proportional.
Inversely proportional.
हा, मग प्रेशर वाढवलं गॅसवरचं तर काय होईल? व्हॉल्यूम
Decrease.
will decreases. By increasing the pressure on the gas molecules comes closer and closer to each other and to the surface of the adsorbent. And therefore what happens? This adsorption increases. Now, if we have to remove this gas from the surface of the adsorbent, adsorbentच्या सरफेस पासून हा गॅस मॉलिक्यूल रिमूव्ह करायचा आपल्याला, तर प्रेशर वाढवलं पाहिजे का कमी केलं पाहिजे?
कमी केलं पाहिजे.
प्रेशर काय केलं पाहिजे?
कमी केलं पाहिजे.
कमी केलं पाहिजे. दॅट इज द गॅस कॅन बी रिमूव्ड बाय डिक्रीजिंग द pressure. Since the adsorption process is exothermic, the physical, as it is exothermic process, what is exothermic process? Heat is evolved in the adsorption process, and therefore the what happens, that is what will be the effect of temperature on the adsorption? Adsorption is greater at lower temperature or it will be greater at higher temperature?
At lower temperature.
Effect of temperature? काय होईल टेम्परेचरचा इफेक्ट? एक्झोथर्मिक प्रोसेस आहे.
टेम्परेचर लेस असेल तर ऍब्सॉर्प्शन जास्त होईल.
हा, बरोबर, गुड. इफ टेम्परेचर इज लोअर, adsorption will be higher. That is the physics occurs readily at low temperature. म्हणजे adsorption हे लो टेम्परेचरला होईल. आणि मग if we have to remove this gas molecule, if we have to carry out the reversible process, that is the distortion, then what is to be done regarding temperature? काय केलं पाहिजे? टेम्परेचर वाढवलं पाहिजे का कमी केलं पाहिजे?
वाढवलं पाहिजे.
वाढवलं पाहिजे, बरोबर. टेम्परेचर वाढवल्यानंतर हे जे मॉलिक्यूल ऍडसॉर्ब झालेले आहेत सरफेसवरती ते काय होतील? It acquires energy and gets detached from the surface. म्हणजे डिसॉर्शन साठी फेवरेबल फॅक्टर्स कोणते आहेत? डिक्रीजिंग प्रेशर and increasing temperature. While for the adsorption, increasing pressure and low temperature. Adsorption will be higher at increase in pressure or increases with increase in pressure, and it takes place readily at low temperature. That is one of the feature of this physical adsorption. Then next, surface area of adsorbent. The extent of adsorption increases with the increase of surface area of the adsorbent. That is, if we increase the surface area of the adsorbent, we have seen that adsorption is the surface phenomenon. That is, the molecule of adsorbent are adsorbed on the surface. Then if we consider, that is, if a surface area is smaller, but that small surface area is available for the molecule of adsorbent, and therefore adsorption will be smaller. जर लार्ज सरफेस एरिया प्रोव्हाइड केला प्रोसेसला तर adsorption will be higher. That is, greater the surface area of the adsorbent, then extent of adsorption will be higher. Now how we can increase the surface area of adsorbent? कशा प्रकारे इन्क्रीज करता येईल आपल्याला सरफेस एरिया ऍडसॉर्बंटचा? काय करायचं? सरफेस एरिया इन्क्रीज करायचा आहे ऍडसॉर्बंटचा. मोठा पीस चारकोलचा घेतला आणि चारकोल पावडर घेतली, कुठला सरफेस एरिया जास्त आहे?
पावडरचा.
पावडरचा सरफेस एरिया जास्त. म्हणजे मेटल्स आपण कॅटलिस्ट म्हणून वापरतो, निकेल, प्लॅटिनम, पॅलेडियम, तर हे मेटल सुद्धा फाईनली डिव्हायडेड मेटल्स. दॅट इज वाय फाईनली डिव्हायडेड मेटल्स का वापरतो? इट प्रोव्हाइड्स द ग्रेटर सरफेस एरिया टू द ऍडसॉर्बेट. जे गॅस आहेत त्या गॅसला ही finely divided metals which acts as the adsorbent provides the larger surface area. That is, we can increase the surface area by taking the fine powder, finely divided metals. Also, porous substance having large surface areas. These are the good adsorbents. Means greater the surface area of the adsorbent, more will be the adsorption. And therefore the finely divided metals are used, and also the porous nature of adsorbent increases the adsorption. Then next, enthalpy of adsorption. Enthalpy of adsorption. Physical adsorption, we have seen that the adsorption is the exothermic process. But the bond between adsorbate and adsorbent is, कुठला बॉन्ड तयार झालेला ऍडसॉर्बेट आणि ऍडसॉर्बंट मध्ये? फिजिकल ऍडसॉर्प्शन मध्ये van der Waals forces. Weak, they are held together by weak van der Waals forces, and therefore the enthalpy of adsorption is, enthalpy of adsorption will be higher or lower? हे फोर्सेस वीक आहेत, वीक फोर्सने हेल्ड केलेले आहे. एन्थॅल्पी ऑफ ऍडसॉर्प्शन विल बी हायर और लोअर?
Lower.
It is lower. It is quite low. It is about 20 to 40 kilojoule per mole in case of the physical adsorption, because the attraction between gas molecules and solid surface is very weak, and it is only due to the weak van der Waals forces. The enthalpy of adsorption, physical adsorption मध्ये कमी आहे, that is 20 to 40 kilojoule per mole. Then next, consider some characteristic features of chemical adsorption. That is the high specificity. Physical adsorption मध्ये आपण पाहिलं lack of specificity. In chemical adsorption, it is highly specific. That is the chemisorption or chemical adsorption is highly specific, and it will only occur if there is some possibility of chemical bonding between adsorbent and adsorbate. That is, when there is the formation of bond between adsorbent and adsorbate, then only there is the chemical adsorption. For example, oxygen is adsorbed on metals because the oxide formation, due to the oxide formation, this oxygen is adsorbed on metals, and hydrogen is adsorbed by transition metals due to the formation. म्हणजे या adsorbent आणि adsorbate मध्ये केमिकल बॉन्ड फॉर्म झालेला आहे. दॅट इज द ऑक्सिजन असेल आणि मेटल सरफेस असेल. ऑक्सिजन गॅस इज द adsorbate, मेटल सरफेस इज द adsorbent, आणि त्याच्यामध्ये काय तयार झालेलं आहे? मेटल बरोबर ऑक्सिजनचं ऑक्साइड फॉर्मेशन इज देअर. म्हणजे तिथं पॉसिबिलिटी आहे केमिकल बॉन्डिंगची, अँड देअरफॉर ओनली द adsorption takes place. Also, hydrogen is adsorbed by transition metals due to the hydride formation. There is the formation of chemical bond between transition metals and hydrogen. Thus, the chemical adsorption is highly specific in nature. म्हणजे कोणताही गॅस, मिक्सचर ऑफ गॅसेस असतील तर त्याच्यामधला कोणताही गॅस सर्टन सरफेस त्याच्या कॉन्टॅक्ट मध्ये आला मेटल्सचा तर तो ऍडसॉर्ब करत नाही. इट ऍडसॉर्ब सिलेक्टिव्हली सम गॅसेस. Which gases are adsorbed? If there is the possibility of formation of the chemical bonding between adsorbent and adsorbate, then only that adsorbate can be adsorbed on the surface of the adsorbent. That is, we can say that the chemical adsorption or chemisorption is highly specific. Then consider about the irreversibility. First point समजला का सर्वांना? Highly specific समजला का?
मॅम रिपीट करता का जरा, लास्ट पार्ट कळला ना.
बर बर. केमिकल ऍडसॉर्प्शन. दोनच मुलं, काय नाव आहे ते त्यांचे? एक 2 मिनिट थांबा जरा. पलीकडे पाटलांचे तर बसते जरा, फारच आवाज येतोय. 2 मिनिट थांबा, फक्त 2 मिनिट. सारखी बडबड बडबड करतात. ते आली वे. हा, आवाज येतोय का आता? हॅलो, काय झालं बरं? एम आय ऑडिबल? कोणाचाच आवाज आहे?
Yes, ma'am.
येस मॅम.
अरे बोला की जरा. माझा आवाज येतोय ना सर्वांना?
येस मॅम.
Yes, ma'am.
हा, तुम्ही दोघच बोलताय, बाकीचे विद्यार्थी कोणीही काही सांगत नाहीत. काय समजतंय का? फर्स्ट पॉइंट मी पुन्हा रिपीट करते, हायली स्पेसिफिक. आता फिजिकल ऍडसॉर्प्शन मध्ये आपण काय पाहिलं तर लॅक ऑफ स्पेसिफिसिटी, म्हणजे त्याच्यामध्ये व्हांडोराल फोर्सेस युनिव्हर्सल आहेत. दोन्हीमध्ये वीक व्हांडोराल फोर्सेस तयार होतात आणि त्यामुळे तो स्पेसिफिक नाही. कुठलाही गॅस त्याच्या कॉन्टॅक्ट मध्ये आला तर वीक व्हांडोराल फोर्सेसने ते त्या सरफेसवरती हेल्ड केले जातात, सॉलिड सरफेसवरती. पण केमिकल ऍडसॉर्प्शनच्या बाबतीत असं नाही. ऍडसॉर्बेट मोलिक्यूल हा ऍडसॉर्बंटच्या कॉन्टॅक्ट मध्ये आला. ऍडसॉर्बंट आपला काय आहे? सॉलिड सरफेस आहे. आणि या सॉलिड सरफेसच्या कॉन्टॅक्ट मध्ये ऍडसॉर्बेट मोलिक्यूल आला. कोणताही गॅस मेटलच्या सरफेसवरती हेल्ड होत नाही फ्रॉम द गॅसेस मिक्सचर. कोणता गॅस हेल्ड होईल? तर त्या गॅसमध्ये आणि मेटलमध्ये बॉन्ड तयार झाला पाहिजे. जेव्हा तिथं पॉसिबिलिटी असेल बॉन्ड तयार होण्याची तरच तो गॅस इट इज केमिकली ऍडसॉर्ड ऑन द सरफेस ऑफ द मेटल. म्हणजे जर आपण पाहिलं एक एक्झाम्पल इथिलीन आणि कोल गॅस आहे, आणि या मिक्सचर मध्ये जर आपण ऍडसॉर्बंट हा चारकोल ऍड केला तर चारकोल फक्त इथिलीनच ऍडसॉर्ब करतो, कोल गॅस करत नाही. म्हणजे त्याच्यामध्ये बॉन्ड फॉर्म होत नाही. देअरफॉर इट प्रिफरन्शियली ऍडसॉर्ब द इथिलीन. तसंच केमिकल ऍडसॉर्प्शनच्या बाबतीत जर आपण ऑक्सिजन गॅस ऍडसॉर्बेट कन्सिडर केला तर तो मेटल सरफेसवरती ऍडसॉर्ब केला जातो, कारण मेटल आणि ऑक्सिजन या दोन्ही मध्ये बॉन्ड फॉर्म होतो आणि त्याचं ऑक्साइड तयार होतं. अँड देअरफॉर इट इज देअर इज द पॉसिबिलिटी ऑफ बॉन्ड फॉर्मेशन बिटवीन मेटल अँड ऑक्सिजन because there is the formation of oxide. Also in case of the hydrogen त्या सरफेस च्या कॉन्टॅक्ट मध्ये आला. कोणते ट्रान्झिशन मेटल्स आपण कन्सिडर केले तर ट्रान्झिशन मेटल बरोबर हायड्रोजन हा हायड्राइड फॉर्म करतो, मेटल हायड्राइड. म्हणजे याच्यामध्ये हायड्रोजन आणि मेटल मध्ये काय तयार झाला? बॉन्ड तयार झाला. असं जर असेल तरच हायड्रोजन त्या मेटलच्या सरफेसवरती ऍडसॉर केला जाईल. म्हणजे देअर शुड बी द पॉसिबिलिटी ऑफ फॉर्मेशन ऑफ द बॉन्ड. याच्याऐवजी मिथेन गॅस ट्रान्झिशन च्या जवळ किंवा मिथेन गॅस हा आहे मिक्सचर मध्ये तुमच्या गॅसच्या आणि ट्रान्झिशन मेटल्स आहेत, तर याच्यामध्ये बॉन्ड फॉर्मेशनची पॉसिबिलिटी नसेल तर मिथेन गॅस त्या सरफेस वरती ऍडसॉर्ब केला जाणार नाही. बॉन्ड फॉर्मेशन होऊ शकतो. बॉन्ड फॉर्मेशन होतो असे bonding between adsorption takes place. Thus, say that the adsorption is
मॅडम
highly
आवाज ब्रेक होतोय.
मॅम
मॅडम
आवाज
हॅलो.
ब्रेक होतोय,
मॅडम
तुमचा
आवाज
नेटवर्क
येत
प्रॉब्लेम
नाही.
आहे, तुम्ही जिथं आहात. आवाज ब्रेक होतोय मॅडम, रेंज नाही आहे त्यामुळं.
समजलं आता?
मॅम आवाज ब्रेक होतोय, तुम्ही बसलाय तिथे नेटवर्कचा प्रॉब्लेम आहे बहुतेक. सर्वांचा आवाज म्हणजे सर्वांना तुमचा आवाज नीट ऐकू येईना. मॅडम लेट.
केतन काय झालं?
अरे मॅम लेफ्ट झालेत. कॉन्टॅक्ट नंबर असेल कोणी तर कॉल करा आणि सांगा त्यांना आता लेफ्ट झालेत ना.
अरे 10च मिनिट राहिलेत ना आता.
तू कर डिक्लेअर झालं लेक्चर म्हणून. थांबा वाट बघा जरा आले तर ठीक, नाही तर मग त्यांना कॉन्टॅक्ट करा करा. थांबा मी करतो 1 मिनिट.
अरे करते कोणतरी.
हा जर ते कॉल केला तर डिस्कनेक्ट होईल मीटिंग, मग कोणीतरी करा मग त्याचे असेल त्याच्याकडे का.
केलाय थांब चॅट बॉक्स मध्ये बघ.
ओके.
नेटवर्क प्रॉब्लेम असल्यामुळे मॅडम म्हटलं 2 मिनिटं थांबा, आता घेतील लेक्चर.
झालंय. ठीक. आता दिसेल. दिसतंय ना प्रेझेंटेशन?
हो दिसते.
We have seen that chemical adsorption or chemisorption is highly specific. That is, when adsorbate is adsorbed on the adsorbent, when there is the chances or when there is the possibility of chemical bond formation between adsorbent and adsorbate, then only that gas, that substance can be adsorbed on the surface of the adsorbent. म्हणजे जर त्या adsorbent आणि adsorbate मध्ये केमिकल बॉन्ड तयार होण्याचे चान्सेस असतील, पॉसिबिलिटी असेल, तरच adsorbate मोलिक्यूल सरफेस वरती adsorbed होतो बाय द फॉर्मेशन ऑफ केमिकल बॉन्ड. That is, hydrogen is adsorbed on the transition metals due to the hydride formation and not methane is adsorbed on the surface of the transition metals by the formation of chemical bond. Means chemical adsorption is preferential or it is highly specific. It only occurs when there is the possibility of formation of chemical bond between adsorbent and adsorbate. Then consider the next feature of chemical adsorption, that is chemisorption involves the compound formation and it is हे रिव्हर्सिबल असणार आहे का इरिव्हर्सिबल केमिकल ऍडसॉर्प्शन
इरिव्हर्सिबल.
व्हाय मी इथं लिहिलंय म्हणून इरिव्हर्सिबल
नाही तिथे केमिकल बॉन्ड तयार होतात ना.
केमिकल बॉन्ड तयार होतात.
आणि परमनंट प्रोडक्ट तयार होतात तिथे ना. परमनंट तिथे product तयार होणार ना.
परमनंट तो प्रॉडक्ट तयार होतोय. काय होतंय ऑक्साइड फॉर्मेशन होत आहे, हायड्राइड फॉर्मेशन होत आहे. म्हणजे केमिकल ऍडसॉर्प्शन इज द इरिव्हर्सिबल process. That is the substance adsorbate is adsorbed on the surface of the adsorbent and it takes place is very slow at low temperature on account of the high energy of activation. Like most chemical changes, chemisorption often increases with rise of temperature. Chemisorption of gas adsorbed at low temperature may change into chemisorption at high temperature. Means for the chemical adsorption, high pressure is favorable for this process, that is chemical adsorption. Also, surface area same for the chemical adsorption also. We have seen that is the greater the surface area, greater will be the adsorption. Like that of the physical adsorption, chemical adsorption also increases with increase of surface area of the adsorbent. Adsorbentचा surface area वाढवला, extent of adsorption increases. Then what is about the enthalpy of adsorption? In chemical adsorption, enthalpy of chemisorption is high असणार आहे का low?
हाय
हाय असेल कारण ऍडसॉर्बेट आणि ऍडसॉर्बंट मध्ये काय तयार झालेलं आहे केमिकल बॉन्ड तयार झालेला आहे स्ट्रॉंग फोर्सेस आहेत म्हणजे एन्थॅल्पी ऑफ केमिसॉर्प्शन इज हाय अँड इट इज अबाउट 80 to 240 kilojoule per mole as it involves the chemical bond formation. And last, that is the state of adsorbent. That is the state of adsorbate also affect the extent of adsorption. That is state of adsorbate means whether it is in a gaseous state or in the liquid state. It also affect the extent of the adsorption. Thus, we have seen about the physical adsorption and chemical adsorption. Then consider the comparison between this physical adsorption and chemical adsorption. So, काय पाहिजे chemical adsorption. We have seen about the physical adsorption and chemical adsorption. And we can differentiate or we can write some points of difference between physical adsorption and chemical adsorption. Physical adsorption आणि chemical adsorption विषय आपण पाहिलेले आहे. त्याचे फीचर्स पण पाहिले. काही कंपॅरेटिव्ह पॉइंट्स आपल्याला सांगता येतील. तर we have seen that the physical adsorption takes van der Waals forces. It arises because of the van der Waals forces. The adsorbate and adsorbent are held together by weak van der Waals forces, while in chemical adsorption, it is caused by the chemical bond formation. Physical adsorption, it is not specific in nature. We have seen about the specificity. That is the in physical adsorption, there is the lack of specificity, while chemical is highly specific in nature. Means physical adsorption is not specific in nature, while the chemical adsorption is highly specific in nature. नंतर रिव्हर्सिबिलिटी बद्दलही आपण पाहिलं तर फिजिकल ऍडसॉर्प्शन मध्ये ऍडसॉर्बेट अँड ऍडसॉर्बंट त्याच्यामध्ये वीक व्हांडरवाल फोर्सेस आहेत. दे आर हेल्ड टुगेदर बाय वीक फोर्सेस अँड देअरफॉर reverse process that is also takes place, that is the distortion. It is reversible in nature, but in case of the chemical adsorption, there is the formation of bond between the adsorbate and adsorbent. It is irreversible in nature. This depends upon the nature of the gas. That is, we have seen that more easily liquefiable is the gas, more is the amount of gas which is adsorbed on the surface of the adsorbent. दोन्हीही nature of gas वरती depends आहे. That is the physical adsorption as well as chemical adsorption also depends upon the nature of the gas. Gases which are easily liquefiable are adsorbed more easily, while in case of the chemical adsorption, it also depends upon the nature of gas, and the gases which can react with the adsorbent shows the chemical adsorption. In case of the physical adsorption, enthalpy of adsorption is low, that is about 20 to 40 kilojoule per mole, while in case of the chemical adsorption, enthalpy of adsorption is high. हे पॉइंट्स आपण पाहिलेले आहेत आता. It is high, that is 80 to 240 kilojoule per mole in chemical adsorption. Also, in physical adsorption, we have seen the effect of temperature. That is, physical adsorption is favored at low temperature. Low temperature is favorable for the physical adsorption, while high temperature is favorable for chemical adsorption. In physical adsorption, it decreases with increase of temperature, while chemical adsorption increases with increase of temperature. Physical adsorption मध्ये weak van der Waals forces आहे, that is no appreciable activation energy is required, but here chemical adsorption high activation energy is required. Both the adsorption depends upon the surface area of the adsorbent. It increases with increase in surface area of the adsorbent, and last, that is, it results into multimolecular layers on adsorbent surface under high pressure. Multimolecular layers means, that is, if we consider the surface of the adsorbent, it is flattened, and on the surface the molecule of adsorbate are held by the weak van der Waals forces of attraction. When we increase the pressure, more and more number of molecules comes closer to this unimolecular surface, and again these molecules are held on first surface by the weak van der Waals forces of attraction. म्हणजे it is a multimolecular in nature, while chemical adsorption is unimolecular in nature. म्हणजे याच्यामध्ये पहिला लेअर जो मोलिक्युलचा ऍडसॉर्ब झालेला आहे सरफेस वरती, त्या पहिल्या लेअर वरती अजून दुसरे मोलिक्युल हेल्ड केले जातात बाय वीक व्हॅन फोर्सेस ऑफ अट्रॅक्शन. परंतु इथे केमिकल ऍडसॉर्प्शन मध्ये एकदाच त्या ऍडसॉर्बेट आणि ऍडसॉर्बंट मध्ये केमिकल बॉन्ड तयार झालेला आहे. म्हणजे केमिसॉर्शन और केमिकल ऍडसॉर्प्शन इज युनिमोलिक्युलर इन nature or unimolecular layer. This is about the comparison between physical adsorption and chemical adsorption. Thus, we have seen about the different features of the adsorption. That is, the adsorption depends upon the nature of the adsorbent, nature of the adsorbate. It depends upon the surface area of the adsorbent, and also we have seen the effect of temperature, effect of pressure. Adsorption is the exothermic process, a reversible character, and selective or preferential process. Depending upon the types of bond formation or the forces between adsorbate and adsorbent, there are two types of adsorption, that is the physical adsorption and chemical adsorption. Physical adsorption is also known as the phygisorption. Chemical adsorption is also known as the chemisorption. And we have seen the characteristic features of the physical adsorption as well as of the chemical adsorption. And last, we have seen the comparative point between physical adsorption and chemical adsorption. समजलं? काय शंका आहे का, डिफिकल्टी आहे काय?
नाही मॅडम.
हा, बर, चालेल. स्क्रीनशॉट पाठवा प्रेझेंटीचा मला ग्रुप वरती. हॅलो,
हा ठीक आहे मॅडम, पाठवलेत मला.
पाठवले का प्रेझेंटी? बर,
अगोदरच्या लेक्चरची होती, आत्ताच्या लेक्चरची नाही येते. आत्ताच्या लेक्चरचे वेगळे असायला पाहिजे, कारण आता फक्त 83 स्टुडंट आहेत.
नाही 118 होते, मध्ये लेफ्ट झाले का मग?
हा मॅडम, आता 83च राहिले फक्त.
मध्ये रेंज गेली तेव्हा लेफ्ट झालेत.
वेगळे, हा.
पहिली प्रेझेंट पाठवा. ठीक आहे.